Hello, ladies and gentlemen. This is Eric Sullivan, your instructor for this video. And in this one, we're going to be talking about doing symbolic mathematics with Python. Now, symbolic mathematics is like the paper and pencil style mathematics that you're used to, where you have an equation to solve and you work out all the details on paper. And you get some sort of symbolic answer. It might have square roots in it, it might have fractions in it, things like that. This is in contrast to numerical programming where you're going to get some decimal answer out. So sympy, to answer the question, what is sympy? It is the Python library that helps us do symbolic math. Right? So it does things like equation solving, it does things like simplifying, it does things like factoring, stuff like that. And really that's what we're going to do in this video. We're going to introduce how to define variables, how to define functions, and then just do some basic things. Function evaluation, expand, factor, simplify, and I'll do a quick symbolic solve. There will be several videos on this playlist that will walk you through how to do lots of things with sympy. So let's jump in. Okay, so variables, functions, etc. Well, okay, if we're going to use sympy, I'm going to import sympy as. Now you can pick your favorite prefix. I'm going to choose SP. It's the one that seems like the most standard and it seems kind of reasonable. Okay, so SP is now the prefix I'm going to use for everything. And the first thing you have to do, if you want a symbolic function or expression, you need to define a symbolic variable. In other words, you're telling Python that the variable that you're dealing with is actually a symbol, not a number. So I'm going to do x equals sp.symbol with a capital S of x, and x is in quotes. Okay, this is a symbolic variable, as compared to a variable that's just going to be storing a number later. Python will deal with it completely differently if it's a symbol. So let's define a function. So I'm going to say like f equals, let's do like x plus 3 to the second, right? So what I would say is on paper, this is f of x equals x plus 3 to the second. Remember, Python does powers as a double asterisk, but take note, I do not have f of x here. I'm defining the name, I'm not defining the variable. So it's actually two lines here where I define the variable, then the name that uses that variable. Whereas on paper, we write that in a much more compact way. That's okay. Let's see what it looks like. Okay, it knows that is a symbolic function. So what? Okay. What if I wanted to evaluate f at x equals 3? In other words, I wanted f of 3 to be something. Well, okay, so f is now a symbolic object, so f of 3 does not make sense. Okay, this will actually give you an error. It has no idea what you're talking about, because the parentheses in Python mean that you're actually going to a Python function and calling on that function, sending parameters in. And I'm using the word function here in a computer science sense, not in a mathematical sense. So what we do instead is f dot, and then I'm going to start typing substitute, f dot subs, and now it wants, let's see, the old and the new. I want x to be replaced by 3. And it gives it to me. Or if I wanted x to be replaced by 4, right, I would say f of 4 is. Now this is a little bit clunky, but it's okay, right? You just have to get used to the fact that I'm doing a substitution. This is you being very literal with the computer and telling it what you're doing. Okay, so that's evaluating functions. Now let's talk about doing some basic algebra. So expand, factor, simplify, things like that. So I still have my function, f. Say I wanted to expand that. So that would be sp dot, well, expand is probably, oh, there it is, expand. Expand f. And let's see what it does. Cool, it multiplies that out for me. That's wonderful. Okay, well, here, let's do this. I'm going to say g is equal to x to the second plus 4 times x plus 1. Let's see what happens when I do the other way. Let's see what happens when I factor. Well, okay, that one didn't factor quite so nicely, but that one did. X squared plus 4x plus 3, this thing, I just said, hey, factor this symbolic object, and it factored it for me, which is great. Now you can also do, I'm going to say h is x to the second plus 3 times x to the second plus x minus 2 times x plus 7 minus x to the third, or to the fourth, right? So it's just some mess here. It has a simplify, so I can simplify that guy. Oops, I should put colons here so this is actually a little bit more readable. There we go. And it actually gathered all the like terms for me, and it actually put them in kind of rank order the way that we would expect. Okay, last thing I'm going to do is just a quick symbolic solve. Now, you spend a lot of time in your high school algebra classes doing like an algebraic solve. Here's an equation, solve for x. Well, sympy has a symbolic solver in the background. So let's come back to my function g. I'm going to say print g, just so we remember what it is. All right, so there's my g. And if I do my solution equals sp.solve, there it is, solve g. Now, what this implies is that I'm solving the equation g of x equals 0. Now remember, g is just the name, so I'm not going to tell it g of x, and equals 0 is implied. And if I do that, well, like I didn't print it off, so solve solution, or print off the solution, and it gives me my two solutions, which we can actually see from the factored form up here. My solutions are -1 and -3. And it gave them to me in numerical order, which is great. So if I wanted the first one, I could do print off solution 0, and then I could print off solution 1. So, and I can even name those things if I wanted to. There's all sorts of other things I can do. But this is a quick intro to what symbolic Python can do for you. Anytime you're dealing with something where you want to do a symbolic solve, where you don't want a numerical decimal style answer, you want to actually do the symbolic manipulation, sympy is your tool. I'm going to go through lots of other things here. I'm going to do some calculus, limits, derivatives, integration. I'll do some plotting, all of that in the following videos. I'll see you there.